P-charts track the proportion of something. Anytime you're monitoring the proportion of something. This particular problem implies that what you're monitoring is the average proportion of defects. The average proportion defective is known to be 1%. What should the upper control limit and the lower control limit of a P-chart be if n equal 25 and z equal 3.0? Oh, we need the formula for the upper control limit and the lower control limit of, and we need to focus in particular a P-chart. The upper control limit of a P-chart is actually pretty simple to determine. It is the average proportion plus z times sigma sub p, the standard deviation in sampling proportions. The lower control limit, very similar. Start with the average proportion and you just subtract out those two values. Now it looks like in this very short problem, actually this is very, very promising. I see the z, right? It says here the average proportion. Yeah, I already have a lot of this information. I'm to use a z equals 3.0, so that's what goes there. And this average proportion defective, that actually is p bar. That's what it's telling us. It's 1%. We do have to be careful with these kinds of calculations to take our percents and to convert them into decimals. Okay, 1% is 0.01. So we've got that and we've got that. The only thing that we don't have is this standard deviation in the sample proportions. Oh, right, because that's the result of another formula. Here's the formula for the upper control limit, here's the formula for the lower control limit, but for a P-chart, you then need a sub-formula, if you will, for that standard deviation. So we remember that this standard deviation sample proportions, big square root, is p bar times 1 minus p bar divided by lowercase n always being, in statistical quality control, the size of the sample. Oh, right, I knew we were going to use this for something that we were actually told here, n equals 25. So now we have everything that we need here to fill this out. So that would be the square root of 0.01 times 1 minus 0.01, or 0.99, divided by 25. Do this first, then take the square root. And I got on my calculator, I did a little rounding, close enough, 0.02. 0.02 what? 0.02. Oh. That's then what we need. Now we're ready to actually answer the question. What's the upper control limit? What's the lower control limit? See how we now have the three pieces that we need in each case? So fill out the formulas. Okay, so I'm going to work down here, have the formula up here. The upper control limit, 0.01, right? That's p bar, plus 3 times 0.02. That's this right here. Well, okay, this 3 times 0.02 becomes 0.06, so the entire result is 0.07. That's the upper control limit, 0.07, or essentially 7%. The lower control limit, 0.01, that's the p bar, minus the same 3, that's the z we're using, times 0.02, and they go, oh, wait a minute, 3 times 0.02 was 0.06, right? So 0.01 minus 0.06 is a negative 0.05. In this particular case right here, we have to be careful. Okay, with P-charts and with their lower control limits, you have to be careful. There is no such thing as a negative proportion. I mean, that's the actual result of the formula, negative 0.05. There's no such thing as a negative proportion. Therefore, when you're calculating a lower control limit and you get a negative number for a P-chart, you reset it to 0. You just say, fine. same thing as 0, because that's the smallest proportion of anything I would ever seen, which means that the p-chart winds up being a little lopsided if you were going to draw it, and this is pretty typical of p-charts. 0.07, imagine this were to scale, right? The average proportion defective we were saying is 0.01, but the bottom of the chart's going to be a lot closer to the average because it's going to end right there at 0. But there you go, there's our p-chart.